Hi, this is Paul. We are doing an AP Computer Science A practice test thanks to Barron's has some online practice tests. So, 40 questions. Let's start with number 1. Consider the following two methods in the same class. We have a change array method. We have a change matrix method. The change matrix method calls the change array method. I think I see where we're going here. We've got a change matrix method. That's going to take a matrix as input, and then for each row of the matrix, is going to call the change array method. Here's the current state of mat matrix, the input, which matrix will result from the method called change matrix. All right. Well, change matrix, we call change matrix, we send this in for i equals 0, I is less than mat.length. What is mat.length? Well, mat.length is 2. Java processes matrices by convention in row major order, so it's an array of arrays. In this case, it is a 2-element array. Each element is a 4-element array. Now, we passed a row, let's say 1, 2, 3, 4, into change array. For int I equals 0, I is less than array length minus 1. Okay, so I is going to go, array length is 4, array length minus 1 is 3, I has to be less than 3, so I is going to go from 0 to 2. Okay, array I equals array I plus 1. So I can see what's happening here. The numbers are being switched. Each number is being replaced by the number succeeding it. So 1 gets replaced by 2, 2 gets replaced by 3, 3 gets replaced by 4. And once that's done, then the last element gets replaced by the first element. So it's a rotation. It is a rotation of the row, right? So instead of 1, 2, 3, 4, we would have 2, 3, 4, and then 1, right? No, that's not right. You kind of get, I don't encourage you in taking these, no matter how simple they look, and you go, oh, I can do that in my head. I don't encourage you to do it in your head. This one kind of lulls you into thinking, well, it's just rotating the row, but that's not right. So we have, here's the initial array, 1, 2, 3, 4. And so what is going to happen is I is going to go from 0 to 2. So that's 3 times through the loop, and each time array at I is replaced by array at I plus 1. So first time through, that changes to 2. Second time through, this changes to 3. Third time through, this changes to 4. Now we're out of the loop, and the final element gets replaced by array at 0, which is not 1 anymore. It's 2. Okay? 2, 3, 4, 2. All right. Let's look at the answers and see if any of them have 2, 3, 4, 2 as the first row. There's the 2, 3, 4, 1. That's the trick answer, 2, 3, 4, 2. So actually, this is the correct answer. What does it say there? Oh, correct. It says we're correct. Okay, good. Next. The Richter scale. Wish that was a little bit bigger. The Richter scale is used to measure the strength of an earthquake. A value on the scale is a real number between 0 and 10. Each step in the scale, for example, from 5 to 6, represents a 10-fold increase in the strength of the earthquake. Consider the following class written by a student. And what? Consider the following segment of a client program, earthquake. So it's going to create a new earthquake class, which is described right here. And it is going to print out quake.getDescription. The Richter magnitude is 4. What will be the output? All right, let's take a look. All right, so we'll pass in 4.0 to this. Let's see, and then call get description. If Richter is greater than 8, it's not. If Richter is greater than 6.5, greater than or equal to 6.5, it's not. Is Richter greater than or equal to 4.5? No. Is Richter greater than or equal to 3.0? Yes. So string is set to earth shakes, no destruction. However, there's nothing there to stop the method at that point, so it's just going to keep going. If Richter is greater than or equal to 0, string equals barely felt by people. So that is going to be the result. And this is not an uncommon type of question on an AP an APCS exam where an if statement or an if-else structure is set up incorrectly so that, the answer that you think you're going to get is not the answer that you're really going to get. So the answer to this would be barely felt by people. Show answer. Oh, wait a minute. No, I didn't want to show the answer. I guess I did want to show the answer. Okay, so yeah, that's correct. Barely felt by people. All right, suppose x, y, and z are variables of type int. Consider the following Boolean conditions. Which of these is true for all values of z, given that x and y have the same value? Okay, that seems important. Wait a minute. What happened to my pen here? Okay. Active pencil, okay, that means as you go through an APCS test, write things down, okay? Don't try to do them in your head, and if you see something important in the question, underline it so you don't miss it, make notes, etc. Okay, active pencil. All right, let's examine the possibilities here. Let's see, number 1, x equals y. That is true. We are given that. And y equals z and x equals z. We have no idea what z is. So we have no idea if x or y equals z. So that is out. X equals y. That is true. Or, okay, now this is something that you will want to know. And that is the logical and or operators have a precedence, just like math operators, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. All right, and takes precedence over or. So this over here, this is all one unit. And frankly, I don't care what that is. We don't care what that is because this will be evaluated second. All right? We don't care if the thing to the right of the or is true or false because this is true. And with the or, only one side of the expression has to be true. We know that x equals y is true, so we know that 2 is true. All right, number 3, x minus y, x equals y. So this is 0. 0 times something equals 0. Yes, that's true. All right, so 2 and 3 are true. I guess that must be answer E, which is the one that we can't see right now. 2 and 3 are true. Yes. Okay. Next, question 4 and 5 are based on the following. Consider the inheritance hierarchy of the classes below. Okay. Classes. All right, so library item is a class. CD and book are subclasses of CD and book are subclasses of library item. First question. I think I need to scoot this over a little so we can see it. Okay. Which of the following declarations will cause an error? Assume that each of the classes has a default constructor. All right, number 1, library item equals a new library item. All right, that's pretty vanilla. That's not going to cause an error. Book, B equals new library item. That's not going to work. What is that? What that's saying is that a library item is a book, and it isn't. A book is a library item, but 2 is not going to work. 3, library item equals new CD. Well, what that is saying is that a CD is a library item, which it is. So the only one that doesn't work is 2. Why am I not able to scroll that? Hang on a second. Let me try scrolling it over here. Oh, there we go. 2. Okay, show the answer. And that is correct. Okay, next question. Same thing. All right, suppose of the 3 classes shown in the diagram, only the library item class has a method called getPrice defined in it. Specification is as follows. It is a public method so that it will be inherited. It returns a double. Okay. Consider the following declaration that appears in a client program. We have an array list of library items. Assume that library list is initialized with library item objects. Consider the following code segment that computes the total cost of all items stored in library list. The use of getPrice in this code segment is an example of. Okay, this isn't really a super clear question. I mean, I think what they mean here is really a book is a library item object, and a CD is also a library item object. And we're going to call getPrice on all of them. Now, CD and book inherit the getPrice method. So it's defined as a public method in library item, but it's inherited by CD and book. So you want to call it on CD or book? Yes, you can do that. It's not overridden. It's not polymorphism. It's not overloaded and a mutator method. No. It's just an inherited method. I think I'm overcomplicating this. The point is that if you define a public method in a parent class or a superclass, that method will be inherited and usable in subclasses. So let's go with that. Okay. I gotta move this back over. Okay. Consider the following method, an array number, we don't have to read through it right now. An array numbers is declared and initialized as follows. What array will be returned as the result of the call do something numbers? All right, well, I think I already said I would encourage you to just write this down. So here is, wait a minute, where's my pen? I would write it down. What do we have? 1, 3, 5, 7. 1, 3. Giving myself a lot of room because I don't know what's going to happen here. 1, 3, 5, 7. All right. And then we have something called num. Current starts out at 0. I is 0. I is less than array length. Okay, so we're going to go through the array one time. Num plus equals array I. Okay, I is 0. We should probably keep track of I as well. I is 0. So we're going to add 1. Num is 1. Array I equals num. All right, so it is 1. Okay, next time through, I is now 1. Num plus equals array at 1. So it is going to be equal to 4. Array 1 is right here. Array I equals num. Okay. So that is going to equal 4. And we go through the array another time. I is now 2. Num plus equals array at 2. So it is going to equal 4 plus 5 is 9. And array at 2 is going to equal num. So that is 9. All right. I goes to 3. Num plus equals array at 3, so that num is now going to equal 16. Array at I equals num. That's 16. Return array. All right, we're done. 1, 4, 9, 16. Okay, scroll this. 1, 4, 9, 16. It's right here. Show answer. That is correct. All right. You know, this is, I don't know, it may be simple enough that you feel like you could do it without writing anything down, and maybe you can. I'm going to leave it up to you. You know, I don't recommend it. So, okay, next. A charity organization has a large list of donor records. Sorted alphabetically by name. Sorted by name. All right. I'm trying to get this thing off of my... okay. Each record contains the amount of money donated in the current year. Which of the following represents an algorithm that will locate the top 7 donors for... Sorry, I think that blanked out for a second. Which of the following represents an algorithm that will locate the top 7 donors for the current year? All right, so here's what you need to know about, well, let's look at C, 7 recursive calls to merge sort. No. I don't see how that's not going to help you. 7 passes through a binary search. No, that is not going to help you. Accessing the last 7 entries in the list. That is not going to help you. So now we're down to insertion sort or selection sort. Okay, so here's the thing to know about insertion sort. If you do 7 passes through the outer loop of an insertion sort, now this says we have a large list. Okay, we do 7 passes through the outer loop of an insertion sort. At the end of those 7 passes, the first 7 elements of the list will, in fact, be sorted. They'll be sorted, but that doesn't guarantee that the largest donors will be included in those 7 items. Okay? 7 passes through the outer loop of a selection sort. Okay, well, so the way selection sort works is it takes a pass through the whole array. It's going to find the person who, the donor who donated the most amount of money, and it's going to put it in the front of the array, first element. Okay, now, it's going to, second pass, it's going to take a pass through the remaining elements and find the largest donor. It's going to move that to the second element of the array. All right, so that's the difference between the way an insertion sort works and the selection sort works. So the selection sort is, in fact, going to guarantee that you get the donors with the most amount of money. If you're unclear about this, please review insertion sort and selection sort, but selection sort is going to guarantee the donors. Okay. Consider a method called outside, okay, that returns true if value lies outside the range from low to high, false if value lies between low, that says and high, inclusive. What? If value, oh, okay, it's true if value lies outside the range. False if it is inside the range. Okay. Let's scroll it up so we can see all of these. All right, so first of all, you can't do this. you can't do this. This is, you can do it in a math equation, but you can't do it in Java. You can't do 2 comparisons at once with that kind of thing. All right, this one, value is greater than low. It's greater than low and less than high. No. If it's greater than low, no, see, no, if it's greater than low and less than high, it's not outside. So that is actually the opposite of what we want. Value is less than low and greater than high. I don't see how that's even possible. Value is less than low or greater than high. Yes, that is the correct answer. If the value is greater than low or, less than low or greater than high, then it is outside the range, right? Why can't I scroll this? All right, let me scroll it over here. Okay. A card which has an int value is represented with the class below. I wouldn't spend a lot of time, reading through the class definition until you have some idea of what you're supposed to do with the class definition. That seems like a time waster to me. Consider an array of card values. Which value correctly changes card in array 0 to have a value of 100? Well, the first one, array 0 equals 100. No, it's an array of cards. It's not an array of integers. So, yeah, no, we can't do that. Array at 0, it's a card, set value 100. Is there a set value method? Yes, there is. It's right here. Set value, we put in the new value, and the value changes to new value. Okay, good. So this one will work. Next one, card C equals array 0. C dot set value is set value 100. Okay, that is exactly the same as this. It's just adds one extra step, which is to assign array 0 to card C. But other than that, it's exactly the same. So 2 and 3 are going to work. All right, let's scroll down and see the. Let's scroll down and see the answers. What did we decide? 2 and 3? Yes, 2 and 3 will work. Okay. Consider the following class definitions. We have a dancer class, we have a ballet dancer class, which is a subclass because it says extends. Ballet dancer is a subclass of ballet dancer is a subclass of dancer. A client program has the following declarations. Dancer, D equals ballet dancer. Is that okay? Yes, because a ballet dancer is a dancer. The next one, ballet dancer equals ballet dancer. Which of the following statements is or are valid? Okay, first option, we can't see all this at one time. All right, B dot leap. All right, so B is just a ballet dancer. Give me a pen here. Leap. All right, that's a public method. So because ballet dancer is a subclass of dancer, it's going to inherit the leap method, and you can call the leap method on ballet dancer classes. So what does that mean? This one, 1 is fine. D dot glide. D dot glide is not going to work. It's I don't know. This is sort of counterintuitive, but D is a dancer object. Granted, it has a ballet dancer. I'm sorry. D is a dancer. The data type is dancer. Now, granted, it has a ballet dancer object assigned to it, but the dancer data type does not have a glide method. It doesn't have a glide method. Ballet dancer has a glide method, but the way this works, it doesn't sort of inherit backwards. That is, ballet dancer is not going to inherit, or however you want to put it, the glide method. Dancer doesn't have a glide method. So you do something like this. Dancer D equals new ballet dancer, and then you try to call D dot glide. It's not going to work. So 2 is out. And then D dot leap, yes, that of course is going to work because dancer does have a leap method, all right, right here. So that's fine. 2 is not going to work. 1 and 3 are going to work. All right, let's try that. Okay. The flip method below simulates a flip of a weighted coin by returning heads or tails every time it's called. The coin is 3 times more likely to turn up heads than tails. Which of the following is correct implementation code? All right, what is it again? it's 3 times more likely to turn up heads. All right, I'm just gonna make a quick note here. Well, I can't write and scroll at the same time. Let's see if we can scroll it up enough to see everything. Yes. Okay, good. Now we can write something. I just want to make a quick note here. And that is, I'll just say 3H. Heads is supposed to come up 3 times more than tails. All right, first one, math.random. Math.random returns a decimal number, a double, between 0 and 1, not including 1. It does include 0, it doesn't include 1. So it can return numbers from 0 up to very, 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 very close to 1, but not 1. All right, so if we call math random and then multiply times 100 and then cast it to an int, right here, we're casting it to an int, we're going to get a number from 0 to 99. We're going to get 100 numbers from 0 to 99. If r is less than 75, return heads. You might say, oh, but it has to be it has to be less than or equal to 75. It doesn't, because we don't have numbers from 1 to 100. We have numbers from 0 to 99. So 0 to 74, that's 75 numbers. And so this, that'll work. That will work. All right, 2. 2 is kind of a simplified method of 1. I mean, so 4 is 100 divided by 25. 3 is 75 divided by 25. It's really the same. It's really the same equations and expressions. Just you divide everything by 25, you get the same thing. In any case, we get what we want, which is that 3 out of 4 times you're going to return heads. So that works. And finally, 3 makes it really simple. It's like, let's just get math random. Let's not do any kind of multiplication or casting, but if it's less than 0.75, which it will be, 75% of the time, then let's return heads. So that'll work also. They'll all work. So 1, 2, and 3 is the correct answer. 1, 2, and 3. Okay. 12 and 13 are based on the following. Consider the following: data, field, and method. Data field is this ARR, and then we have a method, do something. I mean, again, if you want to waste a lot of time, go ahead and analyze that method in detail before reading the question. It doesn't make sense. Just understand that it's there, but read the question first so you have some context within which to parse the method. All right. Which of the following best describes the value of someone? All right, the value of someone. Okay. Let's see, do something. And someone is initially 0. Ignore sum 2. It doesn't say anything about sum 2. For every number in the array, we don't know anything about the numbers in array except that they're integers. Also, do not look at this. Do not look at this. This is something about sum 2. It doesn't ask us anything about sum 2. All right, so num, every number in the array will be added to sum 1 if it's greater than 0. Or if, so what do we have? The sum of all positive values. Yes. No. Well, let's hang on for a second. The sum of all positive values, or we'll take the absolute value. That means now we're dealing with negative numbers. We're already adding all the positive numbers. Negative numbers or 0, non-positive numbers. If the absolute value is odd, so that's odd negative values, okay? So it's all the positive values. I wish we could see this all at once, but I'm going to take that off and say what we have is, and that's enough that we can see it. We have all of the positive values and all of the odd negative values. All the positive values and all the odd negative values. All right. Let's go D. Okay. What describes the value of sum 2? All right. Well, I mean, I see what's happening here. Sum 2. So we can see the answers and the, all right, so sum 2, the number, I gotta get a pen. The number, it's gotta be negative, and it's gotta be even. It's gotta be negative, and it's got to be even. So the absolute value, mod 2 equals 0. Okay. Negative, even values. Okay. Let's go with it. Okay. Scoot this over. Oh, come on. Trying to grab everything right on the line. Move it over. Oh, no. Don't tell me it's going to go back. Okay. Okay. Hang on. Let me get it back. Okay. Let's see. Well, you know, let me just throw this out and then we'll work through it. You can probably tell from what's happening inside the loop there that, okay, so we declare a temp variable, put something in it, and then what we're doing is a swap. We're swapping elements, okay? So A is wrong. B swaps the first and last elements. That's wrong. We're doing it in a loop, so it's not just swapping the first and last elements. Reverses the elements, possibly. Sorts the elements. That looks unlikely. So, yeah, D and E, they look unlikely. This kind of... this kind of thing here, where you have a an array at I, and then you have array length minus I minus 1. Okay. Well, so without saying exactly what the array elements are, 1, 2, 3, 4, 5, 6, 7. If you do something like that, so let's try it. Array I. Array I right here, that I is 0. What is array length? It's 7 minus I, which is 0, minus 1, which is 6. And that would give us this. Okay? What if we looked at this element? This is array at 1. So what is array length? 7 minus 1 is 6, minus 1 is 5. So this array length minus I minus 1, it gives you sort of the corresponding element on the other end of the array. If you do it to the first element, you'll get the last element. If you do it to the second element, you'll get the second to the last element. So it doesn't seem to be it doesn't seem to be sorting anything. It seems to be, if you go through the loop, it seems to be reversing the array, but let's try it. I mean, I think if you have a great confidence in your intuition, you could just go ahead and select C. But otherwise, what I would do is just come up with some kind of sample array. Okay, let's say 1, 3, 2, 4. Okay. Now let's go through it. Mid. We have a variable called mid. It is the array length divided by 2. The array length is 4. Mid is 2. We have a variable called I. I is initially 0. We have a variable called temp. Okay. All right, let's try it. I equals 0, and I has to be less than mid. So it's only going to go through the loop twice. So we say int temp equals array at 0. Array at 0 is 1. And then we say array at 1 equals array at, and we already figured out what this is. If you do that array length minus I minus 1, you get, for the first element, you get the last element. Array length is 4, minus 0 is 4, minus 1 is 3, so it's right here. Array at 1 becomes 4. And then array at 4 becomes temp. So let me do that so it's not sloppy. We have 1. All right, now we're going to go through the loop again. I is now 1. Let's see, int temp equals array at 1. Okay. Array at I equals array length, which is 4, minus 1. Minus 1 is 2. So array at I becomes 2. Let's see. Yeah, 2. Okay. And array at 2 becomes temp. Just going to make that a 3. All right. What was this array originally? It was 1, 3, 2, And now it is 4, 2, 3, 1. All right, so we reversed it. Okay. Scroll this, and it does reverse the elements. It reverses the elements. All right. Which of the following code segments correctly stores in x1 and x2 unequal integers? All right, so yeah, did I say something about like having an active pencil? Yes, they're unequal, right? And they can be, and I know you can't see that, between 10 and, oh, it just goes off the screen. Oh my God. All right. Let's do it one more time. We just can't get everything on the screen here at once. They're unequal. They're integers. That may be important. And they are between 10 and 15. Okay. See, I can't scroll this and write at the same time. Okay. We're going to have to make do without the underlining then. On a real test, I would underline it. Okay. Okay, here I'm going to do it this way. Give me a pen. Unequal integers. Whoa, what happened to my pen? Okay. Unequal integers. And I'm going to say 10 to 15. Okay. First one, you might look at that and say, oh, those are exactly the same, so it's wrong. Well, it is wrong, but not because they're exactly the same. This here, random, okay? They could be different. So math.random times 6 is going to give us a number between 0 and something very close to 6, which we are going to cast to an int. And so it's going to give us a number from 0 to 5. And that is within the range 15. Yeah, but just because it's random doesn't mean it can't be the same. So this one, I don't know. I mean, I don't know if they're equal or they're unequal. I would expect most of the time that they would be unequal, but I cannot guarantee that, so I'm eliminating it. This one is too small. Wait. No, it's not too small. It's not too small. But again, I can't guarantee that those are going to be different. All right. Okay, let's look at the next one. All right, let's see, x1, math random. Okay, so now this addresses the problem that even though what we asked for was random, it might be the same. So then it says, if x1 equals x2, put a new number into x2. Okay, that's a good idea, but again, there's nothing that guarantees that that is going to be different than what's in x1. This is a weird question because I think the probability of calling math random 3 times in a row and getting exactly the same thing back is like infinitesimal. But the thing is that does not work because we could get the same thing 3 times in a row. So it's not going to work. All right, I have to quit the drawing to scroll this so we can see the rest of the numbers. All right. All right, D and E. I'm looking at D and E, and frankly, I'm a little bit puzzled with that. Can I read this question again? Which of the following code segments, each of which can be between 10 and 15 inclusive. All right, this is a tricky question. All right, I'm going to have to reread this, you know, and interpret it a different way than I did initially, and that is that if we're multiplying math random times 5 and then casting it to an int, we're going to get a number between 0 and 4. And so the integers are going to be between 10 and 14. Now, I really didn't understand when I first read that the numbers have to be, it has to be possible to put a 15 in there, because D and E are exactly the same, except that they multiply by 5. One multiplies by 5, D multiplies by 5, and E multiplies by 6. All right, so E will allow us to get numbers from 10 to 15. D will allow us to get numbers from 10 to 14. Now this thing works here a while. The thing that didn't work was the if. That's only going to do it once. Now this will do it as many times as it takes to get a different number in x2, but I'm ruling out D because that will not allow us to get the number 15, whereas E will. So well, that's not, yeah, okay, that's good. So let's go with, so we're going to have to go with E on that. That's a tricky question. Okay, what is the key takeaway here? I guess the key takeaway is that even if you call math random, you are not guaranteed to get a different random number the next time you call math random. But the whole thing is kind of tricky. This thing here kind of looks right. Like, well, if they're the same, let's call it again. Yeah, but you might call it again and get the same thing again. And then this thing, it can be between 10 and 15 inclusive. And I didn't read that right. I just thought, well, it can be between 10 and 15. This could be between 10 and 15. It can't be 15, but it can be between 10 and 15. But what they want is that you must be able to get the 15. So that's it. All right, next. 16 and 17 are based on the following. Consider the following data array, data field and method. Mystery. So we have a private, what is the question? We're going to call, okay, what's the output for string 1 based on a call to mystery. Here's the contents of the list right here. Oh, won't let me do that. I guess that's a picture. Can I underline this? Can't underline anything. Okay. All right, let's try it. Okay, so this is just testing your understanding of the substring method. Substring has one parameter, it has a second parameter. The second parameter is optional. So if we do something like this is string 1. Okay, so we're going to go through every string in the list, and we are going to concatenate to string 1, which is initially empty. We are going to concatenate. If you just put one parameter there, that says I want the substring starting at this index and going all the way to the end of the string. So for what we have here, that would be OG, AT, OW, IRD. And that is answer B. So let's go with that. So I click that. Okay. I bet it asks us about string 2 in the next question. What will be the output for string 2? Okay. If you call out the substring method with 2 parameters, that is the, well, what just happened? I need a pen. If you call it with 2 parameters, I don't know why that is hanging over the top like that. If you call it with 2 parameters, you have the start index and the end index. The end index is exclusive, meaning you don't get the end index. I always think of this by subtracting the first index from the second index, and that tells me how many letters I'm going to get. In this case, 2 minus 1 is 1. So this construct here is going to give us 1 letter. It's going to give us the letter at index 1. It's going to append that to string 2, which is initially empty. So what we're going to get is the letters at index 1, which is, it's not good, O, A, O, I, O, A, O, I. So that is answer A. Okay, let's go there. Show the answer. All right. Consider the following declarations. We have an integer array containing 2, 4, 6, 8. We have an array list of integers, initially empty. Which of the following code segments will correctly add all the elements to list? The final ordering is irrelevant. Okay, number 1, for int I equals 0. So that's just a standard for loop. It's going to go through the array one at a time and add each element to list. So where's my pen? That is fine. Next one, for int I equals array length minus 1 greater than or equal to 0, I minus minus. Okay, well, the ordering of the list elements is irrelevant. It says what this is going to do, it's just going to add them backwards. So it's going to start at the last element of the list, and it's going to decrement I as we go through. Add all the elements to the list. That is fine. This one, it's exactly the same as number 2, except this. Now, you can do this. There is an add method where you can give it an index and add an element at that index, but what you can't do, because I is going to start out at array length minus 1, so, you know, pick, the array, I'll pick the array length. The array length is 4. So we're going to start at 3, and we're going to say list add at index 3 equals, you know, array I, which is 8. But that list is empty. There is no index 3. So what you're going to get is an index out of bounds error. So I guess the key takeaway here is don't, you know, try to add to an array list at an index that doesn't exist. That's not going to work. So the answer is 1 will work and 2 will work. And that is D. Okay. Consider the following classes. All right. Before we do that, let's read the question so we have some context. Move that over. Which of the following declarations in a client class would cause an error? Okay, can you see the whole thing at once? Yes. Okay, pause int, p equals new, pause int, constructor. Okay. if you don't provide a constructor for a class, you will get a default constructor. But if you do provide a constructor, you do not get a default constructor. So there is no default constructor for pos_int, and so this pos_int with no input is not a valid constructor. Pos_int even equals new even pos_int with a default constructor for even pos_int. Okay, that's fine. There is a default constructor for even pos_int, but the even pos_int default constructor, the first thing it's going to do is try to call the pos_int default constructor, because even pos_int is a pos_int. And if there's no pos_int, then there can't be an even pos_int. So it does have to call the constructor for the superclass first. It's going to try to call the default constructor, and there is no default constructor, so that's not going to work. Pos_int, PE equals new even pos_int with a parameter of 10. There is no constructor in even pos_int that takes a parameter. So that isn't going to work. All right, what are the key takeaways here? One, you'll get a default constructor for a Java class unless you implement your own constructors. And in that case, you won't get a default constructor. Also, if you call a constructor on a subclass and you provide no other information, it's going to try to call, well, you're going to have to call a constructor in the superclass. What we have here is you got to make sure that what it's calling actually exists in the parent class. You can't call, for example, in this case, a default constructor that doesn't exist. So subclass will always call the constructor. The first thing will always call the constructor of the superclass, the default constructor. If you write your own constructor, you should write it so that you call the super method and call the constructor. All right, so actually none of these work. Which one will cause an error? All of them. Okay. Oh, it's another one. Suppose the following constructor is added to the even pos_int class, which is a correct implementation for get next even. All right, let's take a look. All right, so this solves one of the problems that we had in the last question on the constructor. So now we have a constructor in even pos_int that does take an integer value. And so then we can call the constructor in the superclass and send that value up there. Now pos_int does have a constructor that takes an integer value. So we're fine with that. It'll take the integer value and it'll put it in this value. All right. Return value plus 2. This is being called from get next even. All right. Value is private in pos_int, so it is not visible to even pos_int, so we can't say return value because even pos_int doesn't know what value is. Next, return get value plus 2. Get value. Yeah, okay, so that's public and it returns the value. We have a getter for it. So that's fine. Number 3, return this plus 2. That's meaningless. The only thing that works here is 2. 2 only. And yes. All right. Halfway through. Consider an array ARR that is initialized with int values. The following code segment stores in sum the sum of all values of all values in ARR. Yeah, that makes sense. Which of the following code segments result in the same value for sum as in the above segment? Let's see. Okay, so enhanced for loop. We'll take every number in array and, okay, no. You can't use the numbers as an index. I mean, you could say sum plus equal num, but you can't use the numbers as an index. That is not going to work. Int sum, yeah, oh, here it is right here. Yeah, this is the right way to do it. You want to do an enhanced for loop, do it like that. Index. I guess that's just a typo. Sum equals 0, index equals 0 for int index in array. No, that's the same. That's the same error as number one. That it doesn't work. You can't take every number in the array and then use it as an index into the array. So goodbye. 2 is the only thing that works, but I mean, just see, we're using enhanced for loops here. You can do this. You can set the index to 0 and you can loop it up to the array length. You can use the index as an index, but you can't use the actual contents of the array as an index. All right, so 2 is that what it's asking? Yeah, 2 is the only thing that's going to work. Okay. Given the following method, it's recursive. Okay. What will be returned by a call to multiply 8? You can try to do this in your head, but what I'm going to do is like this. We'll first call multiply 8, and then we'll go through it. N equals 0? No. N mod 2 equals 1. Is it an odd number? No. Otherwise, return n times multiply n minus 2. All right, so what we're going to have is 8 times m at m, and call it with 6. Okay. All right, let's go through it with 6. Does it equal 0? Is it odd? No. Otherwise, return n times this cursor is slow. I'm just going to do a dot here. N times multiply n minus 2. That would be m at 4. Let's go through that. 4, is it 0? Is it odd? No. Otherwise, return m. That would be 4 times m at 2. Okay. Is 2 equal to 0? No. Is it odd? No. Otherwise, return 2 times m at 0. I'm running out of space. 2 times m. Whoops. I did not mean to do that. M at 0. M at 0. All right. if n equals 0, which it does. So we return 1. All right, so now we can start to unravel this. All right, so we have 2 times 1, 4 times 2, 6 times 4, and 8 times, it's 8 times 6 times 4 times 2 times 1. So let's take a look at what our answers are. Do we have to calculate that? 8 times 6 times 4 times 2 times 1. All right, 8 times 6 times 4 times 2. So that is actually the answer right there. Consider the following declarations. Which of the following tests will return true? Okay, so the key thing here is that strings are objects, and if you want to compare strings for equality, you cannot do, for example, this, where's my pen, this, you can't do that. That is comparing the value of those two variables, and the value of those variables is the memory location of the strings. Now you can do this, so that's comparing objects, and there is an override in the string object to compare strings based on content. Those strings have the same content, so that'll return true. Now strings have a compare to method. So you can say if S1 compare to S2, I think I would have to look up the exact way that works, but you're going to get either a positive or negative number or 0. 0 means they're equal. A negative number, I think it means S1 is less than S2. Could be the other way around. And then a positive number means S1 is greater than S2. You know what? Hang on. Let me give you the right information on that. Okay, so yeah, if you get a negative number on something like 3, that means S1 is less than S2 lexicographically. So what would work here is 1 and 3. All right, good. All right, in the following code segment, you may assume that A, B, and N are all type int. What will happen if A equals B is true? Okay. Let's get that. A equals B is true. So this is false. A not equal to B. That's false. Because it's an and, Java uses a shortcut operator on the and. If whatever comes before the and is false, it doesn't evaluate what comes after the and. So that's important because if A equals B, then A minus B is 0, and you're dividing by 0 here. That's never going to happen because the statement gets shortcut right here. This is false. All right, so then we go to the else. We're going to execute statement 2, and we're going to drop out of the if statement, and then we're going to execute statement 3. So actually, the only thing that I can see here is the correct answer. Statement 2 will be executed, followed by statement 3. Don't be deceived by this and this. Again, the important thing to remember is that and or statements are short-circuit, can be short-circuited, okay? If the first part of an and statement is false, the second part doesn't get evaluated. If the first part of an or statement is true, the second part doesn't get evaluated. So keeping that in mind, it's a pretty easy question. Okay. Consider the method print something, which prints a piece of its matrix parameter, mat. Okay, what will be the output from a call to print something, mat, if mat is as shown below? All right, unfortunately, in this case, we're not going to be able to see everything at the same time. There could be a process of elimination on the answers, but all right, so let's do this. So that's what print something mat looks like. It goes into the print something, and then let's keep track of some variables. We have I. I starts out as 1. And then it's going to go, it's got to be less than mat length, which is 4. Plus equals 2, so the outer loop is going to execute twice. Then we have j. J equals 1. All right, j is less than mat I length. All right, mat I, that's 4. Mat I length is 4. J plus equals 2. So system out print mat I j 1 1, which is right here. Okay. 6. You know what? I don't want to put that right there. It's kind of in the way. Put it over here. I'm going to print a 6. All right, we are going to increment j 3. J plus equals 2. System out print system out print mat ij plus a space. All right, so we have a space here. That is right here. Okay, and then now we are going to print mat ij, which is 1 3 1 3. It's right here. 8. Okay. System out println. All right, and then it goes to the next. Oh, that's weird. Okay. So we go through that, and then we're going to increment j again. So actually, j goes to 5. And we go to the next line, println. Okay? Increment I. I is 3. For int j equals 1, j is back to 1. System out, print mat ij, that's 3 1. So that is 3 1. It's a 0. Mat I 3 1. I'm sorry, 3 1. It's a 4. 3 1. It's a 4. Okay, and a space. Okay. Increment j. J is now 3. Print 3 3. 3 3 is a 6. So we have a 6. Increment j. J is going to go to 5. And then we'll go back out and we have, this will increment to 5 and we are done. All right. All right, so the answer in some format is 6, 8, 4, 6. Let's take a look. I got to erase that. Oh my God, why does it look like that? 6, 8, 4, 6. I mean, the only thing that looks like 6, 8, 4, 6 is this, but I need my pen back. But what happened to the answer does not look right to me. Well, formatting the answer doesn't look right to me because what happened to this? It really shouldn't print all on one line. But with that in mind, there may be something wrong with the way this is, comes out formatted online. But we're going to get 6 space 8 and then 4 space 6. It's the only answer that makes sense. We can't use B, C, or D because it definitely prints a 6, and then it definitely prints a 4. So I'm sorry, it definitely prints an 8. So the only answer that really is plausible there is that. Okay. 26 to 27 are based on the following. Okay, well, we're not going to look at that yet. It doesn't make sense to look at the code without having some sense of the context in which we want to look at it. So, let's go over here. What represents a correct implementation for the increment method? Okay. All right, now we can look at the code here. A number display. It's a class called number display. It's a 2-digit digital display that holds values from 0 inclusive up to not including a given rollover limit. For example, if used for hours on a digital clock, the rollover limit would be 24 and the values in the display would range from 0 to 23. When it goes to 24, it rolls back over to 0. All right. So we need an implementation for the increment method. Let me see how far I can slide this over. Not really far enough, but just let's read that. What is a correct implementation for the increment method? And I'm going to slide it back. 1, if value equals the rollover limit. No, we can't use that because we don't want to check value against rollover limit until we've incremented the value. So that's out. This one, value plus plus. So we increment the value, compare it to the rollover limit, and if we hit the rollover limit, set it to 0. That'll work. Here's another one. Value equals value plus 1 mod the rollover limit. Okay. Not only is that correct, it's probably the preferred way to do it. Using a mod like that. Okay, the example they use is you can go from 0 to 24. It gets initialized to 0, and you keep adding 1 to it. Now, when you get to 23 mod 24, you're still fine. If you get to 24 mod 24 is 0, so it starts over again. So 2 will work and 3 will work. 1 will not work because you can't compare the value to the rollover limit before you've incremented it. So what did we get? 2 and 3? Let's go with 2 and 3. Okay. Same class. Digital clock contains, let me move this over, a digital clock contains 2 number display objects for minutes and hours. What is the most suitable set of declarations? Okay. So this is a composition, an example of composition, meaning objects containing other objects. You want to have a digital clock, and you want to have two number display objects. They're kind of giving it away here. A digital clock contains two number display objects. Okay, so a digital clock is not going to extend number display. It's going to contain two number display objects. Now here we have number display extending digital clock. No. Digital clock extending number display. No. Yes, here's the answer right here. The hours and minutes, you want both of those as number display. As it says, right, can I highlight this? I still can't highlight it. A digital clock contains two number display objects. Okay. This doesn't even make sense. I mean, it has number display objects, but why is it extending number display? We have a digital clock. It contains two number display objects, hours and minutes. They will increment and roll over as intended. So the answer is D. Oh, whoa, 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 whoa. Forgot to look at the answer. D. Show the answer. Okay, correct. Consider the following declarations. All right, so we have class A, and it has a method. Oh boy, this looks confusing. Okay, class A, it has a method. It takes, the method takes two parameters, an instance of class B and an instance of class C. Now, class B is a subclass of class A. Class C is a subclass of class B. A different class has these declarations. Okay? It declares an instance of class A, B, and C, which is a correct call to do something. Which is a which is a correct call. Okay. Do something, do something, do something, do something. Okay. So here's the thing. B is an A and C is a B, but it doesn't go the other way around. Okay. I mean, B is not a C, A is not a B, A is not a C. C is also an A by extension. I think the key thing to look at here is, let me get my pen, this, okay? That method requires that the second parameter be a class C, okay? Now, looking at this, the only call that uses class C as the second parameter is this one, A. None of these are going to work. If you try to call that method with an instance of class A or B, that's not going to work because they are not C's. Now, the do something, which is defined in A, is inherited by B. It's inherited by C. So you can definitely call do something on class C. C is a B, so the fact that this is required to be a class B, that's fine because C is a B. It's a subclass of B, therefore it is a B. You know, the key thing here is none of these other ones work for the second parameter. So A is what we want. Okay. Refer to the static method remove value. It's kind of hard to read. Remove value. It takes as input an array list of integers, a list of integers and an integer value. All right? Remove value, which represents an implementation of remove value that achieves the post condition, which is that it removes all values of occurrences, removes all occurrences of value from list, does not remove any other values. Okay, I can see what's going to happen here. All right, how many choices do we have? Okay, yeah, let's take a look. Okay, let's see. Yeah, so this is not going to work. This this kind of thing will almost always show up on an AP CS exam. What do we have here? A list. Okay, so we're going to go through the list. Here, let me make up a list. 1, 6, 6. Whoa, that went a little haywire. 9 and another 6. All right, now we'll have a counter I. I is initially 0. It's going to be less than the list size. All right. And what is the value that we're trying to remove? Oh, let's say the value that we're trying to remove is 6. So the listed 0, is that equal to 6? No. All right, increment it. So now it's 1. Is the list element at 1 a 6? Yes, it is, as a matter of fact. So get rid of it and increment the value. Is the list element at 2 a 6? Well, because we took that 6 out, we've renumbered the list indexes. So this is actually at index 0. This is at 1. This is at 2. And so we've skipped over that 6. We're not going to remove that 6. That's why this doesn't work. There are different ways of handling this. One is you can remove the items backwards. You can run the index backwards, and you won't miss anything. This one, all right. Never use an enhanced for loop to remove elements from a list. I assume that it gets confused in the same way that we got confused in example number 1. I'm not positive about that, but I do know that you never use an enhanced for loop to remove elements from a list. All right, that's gone. That is gone. Assuming the answers are not none of the above, it's got to be 3. So I equals 0. Yeah, so here's what we can do. While I is less than list size, if you're removing an element, you don't increment I. That'll work. Only increment I if you are not removing an element. So even though this is kind of scratched up here, you can see that in this case, if we went through and we removed the 6 at index 1, then we don't increment to 2. It would still be at 1. And then we would be able to successfully remove the next 6. So the only one that works here is element 3. Element or code sample 3. Okay. Suppose methods, oh no. All right, so they're going to call each other. What is returned as a result of the call F15? Well, let's try it out. Things like this, they take a little bit more time. If you're actually taking the test and you want to go through and, I mean, it isn't that the questions get harder, as the further that you go, they're kind of mixed around. So you will probably get a sense looking at a problem. Oh, this is going to take a while. Okay, do the easy ones first. Just take the first pass through and do the ones that you can do, and you can do them well. Come back and do the ones that are harder, or the ones that are more time consuming. If you run out of time, I mean, you can guess. Don't leave anything blank. If you can eliminate a few choices, then you're better off. But there's no requirement that you start at number 1 and go straight through to number 40. Okay, so here's this one. We're going to start by calling oof. I'm not even sure how to start this, but all right, so we'll call F1 and we'll pass in a 5. Okay. Is x equal to 0? No. If it's not, then return F2 at x minus 2. All right, so now we have to make a call to F2 at x minus 2, and that is 3. So we'll say F2. Yeah, it's not good. Get rid of that. F2 at 3. What does that give us? F2, we pass in 3. Is 3 equal to 1? No. Otherwise, we will return F1 at x plus 1 plus x. All right, so that's 3 plus, oh, I see. Okay. F1 at 4. F1 at 4. Okay. F1 at 4. Right, come on. This is running really slow today. Back here, F1 at 4 plus 3. No. Whoa. What is coming in here to F2? 3? Yes, F1 plus 4 plus 3. All right. The next one, F1, we will call F1 with 4. Does it equal 0? No. If that is the case, then we will return F2 at x minus 2. That's F2 at 2. If we call F2 at 2, what do we get? If x equals 1, it doesn't. Else, return F1 at x plus 1, F1 at x plus 1, which is 3, plus 2. I'm running out of space. What if we call F1 with 3? Does it equal 0? No. Otherwise, we're going to have to go to the next column here. We will have to return F2 at 1. Right? F2 at 1. Okay. F2 at 1. And to get to F2 at 1, at x equals 1, it returns 1. Okay. All right. So F1 at 3 returns F2 at 1, and that's 1. So this, now we have 3. Okay. That goes back up here. So F2 at 2 returns 3. That goes back up here. Now we have F1 at 4, which returns 3, but we have to add 3. That is 6. We go up here. That will return 6, and that will return 6. So the whole thing unwinds to 6. All right. And that is C. Let's try it. Okay, good. Question, okay. We have birds, we have owls, we have hens. Bird is the parent class here. Owl and hen are child classes of bird. What is the correct implementation code for the constructor of the hen class? All right. Well, let's take a look at the hen class. Hen string speed. Okay, so we need an implementation. The first thing that you need to do in a subclass is call the constructor of the parent class, which in this case is bird. What does the bird constructor look like? The bird constructor takes a string. Okay, so number 1, just calling calling super with no parameters, that's not going to work. Bird does not have a default constructor. 1 is not going to work. 2, super with a species, that's going to work because that's what the bird constructor looks like. 3, species equals a species. That's wrong. It's wrong because the species property in bird is private, and so hen doesn't know anything about it. So 1 is wrong, 3 is wrong, 2 is correct. All right. All right, we got another one. A client class has an array list of type bird. It's initialized with many different objects that are subclasses of bird. Each subclass has an overridden make noise method, similar to those shown in owl and hen. What is the effect of executing the following code segment? For B in birds, B dot make noise. Well, let's take a quick look here. Well, actually, let's look at the possible answers. The unique noise for each particular bird will be output. That sounds right because it's this is a polymorphism where you have a hierarchy of classes, and there's a method in the parent class, and it's overridden in child classes. Compile time error. No, that's no. Index out of no. It's all these everything is an exception except the right answer. No, I mean let's look at it. So bird has a make noise method, the implementation of which is not important. Owl extends bird. It overrides the make noise method. That's a public method, right? Yes. And it's so it's going to print hoot for an owl. Hen extends bird. It has a make noise method. It overrides the make noise method in bird. It says cluck, cluck. So now if you've got a list of bird objects, possibly including subclasses, the appropriate make noise method is going to be called for bird B in birds. Okay. The result, again, is polymorphism. The result is different depending on the actual class that is in the bird object. Again, it could be a hen, could be an owl, but it'll call the appropriate make noise method. So the unique noise for each particular bird will be output. Okay. What do we have here? Oh my God. Recursion. Double recursion. What will be returned by a call to mystery 2? All right, let's try it. We've got, put this up here, mystery 2. Okay. If n, which in this case is 2, is less than 0, return 1. Okay. Otherwise, return mystery at n minus 1 plus mystery at n minus 2. All right. So we've got mystery at n minus 1. That would be m at 1. Sorry, that's a little sloppy. To 1. Plus mystery at n minus 2, which is m at 0. Okay. All right, let's call m1. Is 1 less than 0? No. So what we need is mystery at n minus 1, which is m at 0, and mystery at n minus 2, which is m at negative 1. I didn't mean to put that there. M at negative 1. Okay. We actually know the answer to this one. This one here is 1. Because if we call m mystery with a number less than 0, it will return 1. Okay. M0. If we call mystery 0, n is not less than 0, so it's going to return mystery at negative 1, mystery at negative 2. Okay. Those are both less than 0, so in each case they will return 1. We'll add them together, and the result of m at 0 is 2. So we actually know the result of m at 0 over here, which is 3. Okay, so no, m of 0. If m of 0 is 2, m of 0 is 2. So we add these together. So that is going to return 3 up here. And the m2 call is going to return 3 plus 2, which is 5. So let's go with 5 as the answer to that. Okay. An array of hospital records is sorted by patient ID number. Suppose a patient's record must be located given the patient's name. Which of the following procedures is the most efficient for locating that patient's record. Okay, so which of the following procedures is the most efficient? 1, do a binary search. No, we can't do a binary search because the records are sorted by ID numbers, and we want name. Do a sequential search. Yes, that's not a bad idea. I mean, what we're going to get, the sequential search is, I forget how much they cover this in AP Computer Science A, but that is O of n. So the runtime is proportional to the number of elements, O of n. All right. Next choice, so, sort the array and then do a sequential search. Okay, so first of all, we can't do this. If you're going to do a sequential search, there's no reason to sort it ahead of time. All right. Start with the first record, examine every 5th record. Then start with the second record, examine every 4th record. That's nonsense. Here's another possibility. Sort the array alphabetically and then do a binary search. The best sorting methods that we have are O of n log n log n. That is worse than n. So the best way that we have is to do a sequential search. I mean, there's more that could be said about this. I mean, if, well, you know what, that's for what we're given here, the best approach is you're just going to have to do a sequential search. All right. Okay. Which of the following are false? Number 1, a subclass inherits all the constructors of its superclass. No, that is super important. It comes up all the time. You never inherit constructors, never. Constructors are not inherited, so 1 is false. 2, a subclass inherits all the private instance variables of its superclass. Okay, again, that's super important. Private variables or methods are never inherited, never. So 2 is false. Number 3, a subclass inherits all the methods of its superclass. Well, again, that's kind of what we just covered, although they said private variables. No, if a superclass has private methods, those are not inherited. So 3 is also false. And so the answer is 1, 2, and 3 are all false. All right. Wow. Oh boy. Oh boy. All right. 2D array time. Precondition mat is initialized with integers. Postcondition mat has a border of num. Mat is a matrix of integers, a 2D array. Param num is the border to be placed on the value to be placed on the border of mat. For example, if we originally have a matrix like this, and we call make border mat 9, what we get is a border of 9s around the outside of that array. If mat is originally this, there really is no inside of the array. So make border mat 2 will change mat to be a bunch of 2s. All right, so which of these, what is the question? Which one will work. All right, number one, for int r equals 0, r is less than matrix.length. Okay, so we're going to process each row. All right, for each row, we are going to process each column. So we're going to process, we're really processing the cells, each cell one at a time, left to right, top to bottom. Okay, now for each cell, if it's in row 0 or it's in the last row of the matrix, that's the r equals mat length minus 1, or C equals 0, the column equals 0, yeah, or if it's in the first column or it is in the last column. If it's in the first row, first column, last column, set it to num. Yes. Okay, so that'll work. That'll work. One will work. This is not an easy problem. For int c equals 0, c is less than mat 0 dot length c++. So we're processing. All right. Mat 0. Okay, so mat 0, and then we're going to run c from 0 to the width of the matrix. That is going to fill the first row. All right, the next one there, mat length minus 1, c, where we're running c from 0 to the, well, actually 1 less than the matrix width. That is going to fill in that for loop is going to fill in the first row and the last row. First row, last row. Okay, next, for int r equals 0, r. Okay, so now we're going to process the rows. All right, in each row, we're going to set the first number in the row to num. And then we are going to set length minus 1, the last number in the row, to num. Okay? Yeah, that'll work. That'll work. There's a little bit of a duplication of effort there in that some of those cells will already be set by the first for loop, but that'll work. The next one, how is 3 different from 2? For int c, the first for loop looks exactly the same. The second for loop, well, the second for loop, the inside the brackets it's the same, but the index is different. Instead of running it from 0 to mat length minus 1, it's gonna run from 1 to mat length minus 2. But that's okay because as I said, this is really duplicating some effort here. If you want to go to row 0 all the way down to the last row, what you're going to find is that this first for loop has already processed the first row and the last row. So there's no need really to process the first row and the last row. So if you wanted to do this, start at the second row and go to the second to last row and set the first and last numbers, then that would work also. You can, try this for yourself on a piece of paper if you want to satisfy yourself that it would work. But it is 1, 2, and 3. 1, 2, and 3 would be the correct answer. They should all work. Okay. Consider the following declarations. Okay, we have a name class, we have an employee class. Okay. In a client program, which of the following correctly declares and initializes employee emp, whose name is Ben, M. Zach's ID number is 1492. Which of those is going to work? Well, okay. Let's see. Can we get this so we can see everything at the same time? I can see 1 and 2. All right, so let's try this. Employee emp equals new employee. I don't think that's going to work because there is no default constructor for employee. If you want to construct an employee, you need a name and an ID number. So 1 is not going to work. 2, employee emp equals new employee string integer. That is not going to work. Again, it doesn't match with the constructor. The constructor requires a name as the first parameter, not a string. So 2 is not going to work. All right, let's go to 3. What is name here? Name, we can create a name with a first name, a middle initial, and a last name. All right, so let's look at this. Employees, emp. Well, you know what? I mean, there is none of the above, so we can select this already, but I mean, let's take a look at it. New name. We can create a name with these 3 strings, and then we can call the employee constructor with a name and an integer. Employee constructor requires a name and an integer, so 3 should work. Okay. 37 and 38. Consider the following declarations. Oh, I see. Wait a minute. Is this 38? Oh, it is. So it's the same thing. It's the same name and employee. Of the following, which is the most appropriate header in a static client class for a name match method that determines whether 2 employees have the same name? Okay, so this brings up some good points. So there's a name match method. It's going to determine whether 2 employees have the same name. Okay, what is going to be the return type of that method? I mean, it's going to be Boolean, right? Do they match or do they not match? True or false? So void is not going to be an appropriate return type. Okay, so let's rule those out. Let's see. Now at this point, you will probably have seen that you can write methods in a class that take as input another object of the same class and determine their equality. Okay, but this is not what's happening here. This is a static client class. This method is not in the employee class. It's not in the name class. So there's no way that you can write in a client class a method that takes 1 employee or 1 name and determines whether it matches some other name that you're not even providing. Well, that just kind of narrows it down a little bit. But so let's look at E. I got to scroll it up a little bit. But this will work. It's Boolean. It'll return a Boolean. If you give it, you're going to give it 2 employees, and you're going to figure out if the name matches. So yeah, that's really the only one that makes sense. All right. Following method is intended to return the index of the smallest word in the array words, namely the word that would appear first in an alphabetized list of the strings in the array. Okay, I'm not going to read it yet until I see what the question is. Which of the following should be used to replace condition so that find min works as intended? Okay, good question. Let's see what's going on here. Min pos equals 0. We're going to start with index at 1. If condition min pos equals index. If condition. Okay. So we're not looking at the... Oh, okay. So we're not looking at the first word. We're starting with the second word. Pos equals index. Now, what is this? Okay, it returns the index. Okay, that's fine. So the first thing is to understand the strategy that they're employing here. Min pos equals 0. Fine. So whatever the first word is, we don't know what it is. We're not looking at it. We're starting at index 1, and then we are going to go through the rest of the words in the array. Min pos is going to be kind of a holding cell for the index of the min word. So we will move index to min pos if the word at words index, and we're going to have to do a compare to, which is a string method, compare to, we will do a compare to words at min pos, and it should be less. If it's less, that means that we have found a word that is lexicographically smaller in, well, what are they saying here? Yeah, the smallest word. We found a smaller word. So what do we have? Yeah, as we go through here, if we find a word that is less than the word at the min pos index. So words index compared to words at the min pos index. Yes, it has to be less. That means that words index is smaller than words at min pos. So words at min pos, it's no longer the smallest word. So what is the key? What is the key takeaway here? Understanding what they're doing with the algorithm, and then understanding how the compare to method works on strings. Let's take a look at the answer. All right, that's it. There's only one more question. Consider the following static method, count diff. Method count diff is intended to count the number of different values in array ARR. It does not, however, work as intended. Hate when that happens. Lines are numbered for reference. So what's the question? Which of the following changes should be made so that count diff will work as intended? Okay, well, let's see what it's doing. So precondition array ARR contains int. Oh, it contains int values, and it's sorted in increasing order. Well, I wonder if what they mean is it's sorted in like non-decreasing order. If it's sorted in increasing order, then they're all distinct. Returns the number of distinct values in array. Okay, so what do we got? We got count is one. Count is 1. Should be changed to count 0. I don't really know. Let me think about that for a second. So if we have this and this, we're going to go we can only make one change, right? Okay. I is 0, I is less than array dot length. If that is not equal to that, add to the count. I mean, it's probably all right. Okay, there's the problem right there, actually. Okay, this is a really common problem. And that is, you want to do a loop. You want to do a loop from 0 to array dot length. So I is going to go from 0 to whatever to 1 less than well, it's going to go from 0 to the maximum index, okay? If you do that, don't do this, because you're going to overflow you're going to overrun the bounds of the array. I mean, let's pick a number. We've got an array of size 10, and so the indices will go, wow, that's a great 10. The indices will go from 0 to 9, okay? And then when we get down here, say, well, does array at 9 equal array at 10? There is no array at 10. So that's going to cause an error. And there's only one thing we can fix here. So that's what we got to fix, is we got to stop that from overflowing. Typical way to do that is to run the index from 0 to array length -1. And then you will not overflow your array. Okay. Okay, here is, yeah, B. B looks like what we want to do. A is wrong. 11, no, 11 is wrong. 16, return array length minus, I don't know what the other ones are doing, but this has to happen because this is going to overflow the array. So it's a common error, and one that you need to constantly be on guard for. Okay, this answer is correct. Okay, submit the section. Yes, let's go ahead and submit. Free response. Okay, we will continue that on another video, but that is it for the multiple choice questions.